Now we could do the same exact question with synthetic division. So as I said, we found what p of x, that x minus 1 is a factor of p of x. And p of x is equals to x to the power 4. Let me just quickly find it. Give me a second. P of x is equals to plus x3 minus 13. That's a really bad 3, I'm so sorry. 3x squared minus x plus 12. Okay, so we have our little chart method or synthetic division. X minus 1. So our factor is 1 and we separate it by a little box. I like to do half a box, it just looks better. And then we carry down all of the coefficients. So we have 1, 1, negative 13, negative 1, and then plus 12. Or just 12. Now what we do is we carry down, this is our answer line, we carry down the first coefficient. Now what we do is we multiply our factor by the carried over answer, which is 1 times 1 is 1, write it right underneath the second coefficient, and then we add these two. So 1 plus 1 is equals to 2. So if you want to see it in a more detailed way, what we do is this is multiply, and over here the answer gets written over here, answer. Now with the answer we add these two, then we write the answer right underneath the answer line, and that is it. We continue this process all the way until we reach here. So let's do that. 1 times 2 is 2. Negative 13 plus 2 is negative 11. We're good there? Now we do 1 times negative 11 is equals to negative 11. Negative 1 plus negative 11 is equals to negative 12. Now negative 12 times 1 is equals to negative 12. So 12 plus negative 12 is equals to 0. Again, as I told you, this over here, that is our remainder. Since our remainder is 0, that means we have proven that x minus 1 is a perfect or is a factor of p of x. This over here is the rest of our factors. This is now x to the power 3, x to the power 2, x, and this is our constant. Remember, this was x squared, x to the power 4, x to the power 3, x to the power 2, x, and this is a constant. We moved it down by 1. So now our new p of x, or p1 of x, is equals to x to the power 3 plus 2x to the power of 2 minus 11x minus 12. Again, we need to find the x value for which p1 of x is equals to 0. We found that in the last question, and that was negative 1. So x plus 1 is a factor of p1 of x, therefore it's also a factor of p of x. Now what we do is we perform the same procedure. Now since we have it as negative 1, we separate it again, we write down all of these, which are 1, 2, negative 11, negative 12. We carry over the 1, and we do the same steps over again. Negative 1 times 1 is negative 1. 2 plus negative 1 is equals to 1. Negative 1 times 1 is negative 1. Negative 12 plus negative 1 is negative 12. Negative 12 times negative 1 is 12. Negative 12 plus 12 is equals to 0. So what we get now is, this is again our remainder, so we don't care. We have x squared, x, and a constant. Therefore, I'm going to write it over here since we're running out of space. P2 of x is equals to x squared plus x minus 12. From here, again, we don't have to use the integral zero theorem. We could just factor it as we usually do, which would mean we could find what multiplies to negative 12 and what adds to positive 1, which would actually be x plus 4 and x minus 3. Therefore, p of x can be written or can be factored to x minus 1, x plus 1, x plus 4, and x minus 3. This is the exact same answer we got using long division, but as you can see, this process is much faster. But to understand this process, you must first of all understand long division, which is why, personally, if you can use this, you can always rely on it and trust it to make your life easier than doing long division. And yeah, that's it for this example, so let's go back to the slides.